Hello, I'm going to show you how to deploy a containerized web app with AWS CoPilot. AWS CoPilot simplifies the deployment of web apps by automating the creation of architecture behind the scenes. There are four options for CoPilot, two of which we'll focus on today, which are load balanced web apps and request-driven web services. The difference between the two is, though they're both publicly facing, is how the architecture supports the app. In the case of a load balanced web service, AWS will create a load balancer and use ECS and Fargate to deploy a number of instances of the container behind the load balancer. This will allow for an application that experiences consistent flows of requests to stay up and scale if necessary. The other option, a request-driven web service, will use AWS App Runner. The advantage to this is that for applications which experience infrequent traffic or spikes of traffic, it will warm up and it will provide the application as requests are coming in. So this is a better choice for infrequently accessed endpoints. So those are the two options, but it turns out that the deployment will be pretty much the same. The only difference is that you'll select as you're deploying either load balance web service or request driven web service, depending on which one you want. So in the last video, I already talked about how to set up your AWS CLI, and I've also mentioned that that configuration will extend to the CoPilot CLI as well. So what I'm going to do is I'm going to be deploying a web app. What this web app is it is a NLP model that's been deployed in Flask in a Docker container. So it's a containerized web app. In particular, it does some machine learning stuff, but that's not going to be relevant for the deployment of it. In particular, in the deployment, what we need to know is that this is a Flask app. Actually, we don't really need to know that, but we need to know it's a web app. We need to know what port it's going to run off of. And it's important to set up the Docker file like this. In particular, there is no port mapping in AWS CoPilot. So what you'll have to do is you'll have to internally use the same port that you wish to use when you deploy it. Now, another thing in this Docker file worth mentioning is I expose port 80. This is not strictly necessary. In fact, expose is just a note to other programs or other users. But in this case, AWS CoPilot will see this expose 80 here, and it will know what port we want to run the service on. Now, in order to make sure the app's doing what we want it to do, let's have a quick look at it, and then we can test it when we get it deployed. So right now, the app has two routes. The first route is just a route that's going to tell what its status is. Basically, if it's up. If it isn't up, this route won't work. And then there's another one that will take a post request of JSON type with a key text and a value of whatever text you want to identify as ham or spam. And that's the app. In another video, I'll show you how to make this application, or in particular, how to make this machine learning pipeline. But for now, it's just available as a pickle, which we can simply load. So with that, let's go ahead and get started deploying this application. I've already cloned this application to my computer. I'll provide the link to the repo, which is publicly accessible as well, and y'all can have a look at that. So right now I'm in the directory where it is, where the application is. Now what I'm going to do is I'm going to go and deploy the app. I'm in the repo, which I have downloaded. And from here, since I'm already authenticated into the AWS CLI and therefore the CoPilot CLI, all I have to do is CoPilot init. It'll ask me a few questions. Now it's asking me if I'd like to use one of my existing applications. I'm going to select no. If you haven't used CoPilot before, you won't see this. So you may or may not see this. If you've never used CoPilot before, this option will not come up. And I'll hit no. But anyway, this is what it would start if you had never sent one, deployed one before. So it's asking me for a name. Let me call this spam detector app. So I'm going to select load balanced web service. You could also select request-driven web service if you wanted a public endpoint. If you didn't care about an endpoint, you could select backend service, and you'd have to handle networking this inside your AWS VPC. However, to make things simpler, I'll just select the load balanced web app. It's asking for a name for this load balanced web service, and I'm just going to call it the same thing I called the app. And now it's going to ask me what Docker file I want. It automatically detects anything starting with Dockerfile. I have two Docker files in the repo. One called Dockerfile, which I've used locally, and also have used in another video, which is forthcoming, to do this with GCP. But here I want this CoPilot one. So I'm going to select this one. And the important thing is in this file, I have the expose statement for the port, and I make sure that when I boot GUnicorn, I bind port 80 because I have no port mapping here. The internal port and the external port have to be the same. And this will create some of the infrastructure for the spam detector app application. In particular, what this is going to set up is ECR as a place to put the container once it's built. This will take a minute. So it's set up the ECR, and it says I'm set up for local development. I want to go ahead and deploy a test environment. Now, there's production environments available as well. They are essentially the same, though. They just use more resources. There's more instances behind the load balancer. There's more throughput, etc. So a test environment will actually be a real deployment. It just won't have as much power as a production deployment. So I'm going to go ahead and hit yes or Y, and this will go and it will make some other architectural changes. Then what's going to happen after a minute is it's going to build the Docker container locally. So it's important that I have Docker running for this. Then it will push the Docker container to ECR, and from there it will make a few more architectural changes, deploy the container, and it will give me the URL where the app is hosted. So it just created the environment. At this point, it's doing the Docker build, which is happening from the local computer. And then once it builds, it's going to push it to ECR. All right, so it just finished pushing. Now it's making a few additional architecture changes. This will take a minute as well. And that's it. It's done. It's now available at this URL. So let's check it out. So this will hit the home route, which is just going to tell me whether the app is up or not. And it looks like it's running. Let's make sure the post route works as well. To check this, I'm going to use Postman. I'm going to use this URL, and I'm going to go to the predict route. I'm sending a post request, and in the body, I'm sending it a JSON. It's also worth mentioning, I've set in my headers content type to be application JSON. The text it's going to send is the text some text, and let's see what it gives us back. So the model, the endpoint, predicted that this result was ham. It wasn't spam. So it looks like we're good and everything's up. Now, another nice thing about AWS CoPilot is it makes it very easy to deprovision that architecture and shut everything down. Instead of having to go in manually and shut down this huge number of different services, CoPilot makes it very easy for us. So to shut down an application, its stack, etc., all we have to do is run CoPilot app delete. It'll ask us if it's sure we want to delete, and we're going to hit Y for yes. It's going to take a few minutes to delete, but everything else will proceed without any more intervention from us. And this will allow you to experiment with a deployment, test it out, but then deprovision all this architecture so you're not charged. And that's it. I hope you enjoyed this video. I hope you see that CoPilot has really simplified deploying containerized applications to AWS as opposed to using some of the underlying services directly.